launching system disguised as ordinary wooden cabins mounted on the backs of cargo trucks. These mobile containers looked like simple rural sheds, but inside they held reinforced structures, hidden launch platforms, battery charging stations, and remote-controlled roof mechanisms. The design allowed for drones to be launched either vertically or at an angle, depending on their type, while built-in signal shielding helped them avoid early detection by Russian surveillance. Once these mobile silos were ready, Ukrainian intelligence operatives, possibly with help from local sympathizers, moved them deep into Russian territory. The trucks were quietly driven to pre-selected sites near key airbases, parked in places like forests, farms, or industrial areas where they blended into the landscape. They remained dormant for days or even weeks, with drones preloaded, charged, and waiting for the command to strike. When the time came, encrypted activation signals were sent remotely. The roofs of the containers slid open and the drones lifted off, some vertically, others using ramps or compressed air launch systems for a silent start. Because the launch sites were positioned just a few kilometers around 2 miles from their targets, the drones were able to reach their objectives quickly, leaving little time for Russian defenses to react. Operators guided them in real time using live video feeds, steering the drones with precision toward parked aircraft, fuel depots, and radar installations. Many of the drones carried high explosive or shape-charged warheads designed to pierce aircraft fuselages or ignite fuel stores. Some exploded on impact, while others used delayed fuses to cause maximum damage after reaching their targets. The operation was more than just a tactical win. It highlighted the growing sophistication of drone warfare and Ukraine's ability to strike deep inside Russian territory. In total, 117 drones were launched in a highly coordinated attack that hit at least 5 major airbases. Among the targets were strategic bombers, including aircraft Russia no longer manufactures, making their loss even more significant. These are the area where Ukraine struck 34% of Russia's strategic bomber fleet. Ukraine targeted strategic nuclear bombers at the Belaya Air Base in Siberia. Other key military installations also came under attack, including the Ivanovo Air Base northeast of Moscow and the Dyagilevo Air Base south of the capital. A massive explosion rocked the Arctic city of Severomorsk, home to Russia's largest fleet of nuclear submarines. Ukraine also struck the Olenia Guba naval base in the Murmansk region. Reaching as far as Siberia, the operation inflicted serious damage, reportedly destroying or disabling a significant portion of Russia's strategic bomber fleet. The strike marked a turning point, not only in the conflict itself, but in the evolution of drone warfare on the modern battlefield. Among the high-priority targets were the Tu-95 and Tu-22 strategic bombers, aircraft frequently used by Russia to launch cruise missile attacks deep into Ukrainian territory. The A-50 airborne early warning and control aircraft, vital for coordinating Russian air operations and detecting incoming threats, were also targeted. According to Ukrainian sources, the impact of the strike was substantial. More than 40 aircraft were reportedly hit. While some were completely destroyed in the explosions, others suffered significant damage, rendering them inoperable for extended periods. There are reports suggesting that Ukraine may have been using fiber optic control systems, which are immune to electronic warfare jamming. At the front of the drone is a camera with an RPG warhead positioned just below it. The warhead is flanked by 2 batteries located here and 4 propellers. However, the drone has a downside. The added weight with the fiber optic reduces its flight time to just 15 to 20 minutes, and its range is limited to only 1 mile or less. This, when compared to a standard drone without fiber optic, it travels more than 5 miles, which translates to around 10 kilometers. To understand how Ukraine launched these FPV drones, let's take a look at how they are made. First, we have the carbon fiber frame, which provides a lightweight yet strong structure. The frame is designed to withstand the stresses of high-speed flight and collisions. Next, you'll notice the 4 propellers, each connected to its corresponding motor. These propellers are strategically designed with opposite angles to ensure smooth and balanced flight. This counter-rotation helps the drone maintain stability and agility during flight. All of this advanced technology requires a central processor, or what can be considered the brain of the drone. This role is played by the thin motherboard placed here. As you can see, these are not covered, which helps in reducing weight. It manages all the flight operations, processes data from sensors, and translates commands from the remote control into action. Moving to the back of the drone, we find the cables that connect the motherboard to the power supply, which is provided by the battery. The battery is one of the heaviest components of the drone due to its energy density. Depending on its size and capacity, the battery can power the drone for anywhere between 20 to 30 minutes. Next, let's move to the propellers and motors also need power and precise instructions to function correctly. They are connected through a series of cables located here. Both supply power and transmit control signals from the flight controller. These cables are exposed to minimize weight, ensuring the drone remains as light and efficient as possible. At the front of the drone, you'll find a camera that is connected to both the motherboard and the radio receiver, allowing it to transmit live video footage back to the pilot. This setup enables the pilot to see exactly where the drone is flying in real time, providing crucial visual information for navigation and target acquisition. However, modern warfare has introduced new challenges. For instance, Russian forces are increasingly utilizing electronic warfare systems. These systems work by jamming the radio signals between the drone and its pilot, effectively disrupting communication and control. When this happens, the pilot loses the ability to see and control the drone, which can lead to mission failure. To counter these tactics, the Ukrainians have developed an effective solution, deploying an additional drone to act as a signal enhancer. This secondary drone strengthens the connection between the primary drone and the pilot, ensuring a stable link even in the presence of electronic interference. By boosting the signal, this method helps to neutralize the impact of the enemy's electronic warfare units. With this enhanced connection, the pilot regains control and can continue to maneuver the drone toward its designated target, maintaining operational effectiveness despite the enemy's attempts to jam communications. Finally, we have the warhead located here at the bottom. This particular weapon is an RPG, or in full-form rocket-propelled grenade. If we take a closer look inside, we can find the piezoelectric trigger. This trigger mechanism is housed within the RPG warhead and features an air-filled cavity with a conical liner. However, this trigger might not function as intended if the drone is moving too slowly or if it strikes a solid mass, like a tank not in full force. In such cases, the piezoelectric trigger may fail to activate. To address this, an additional trigger mechanism has been installed at the front of the warhead to ensure it detonates on impact. Let's examine this warhead more closely. At the front, you'll find the piezoelectric trigger. The piezoelectric trigger is a device that generates a voltage when subjected to deformation, exploiting the piezoelectric effect. Its purpose is to measure changes in pressure, acceleration, temperature, strain, or force by converting these changes into an electrical charge. Just behind it, there is an air-filled cavity and a conical liner. This explosive is intentionally inverted, and this configuration is designed to create a high-velocity jet of heat. This jet is meant to penetrate lightly armored vehicles, or in some cases can even damage a main battle tank. Once the booster propels the rocket out of the tube, the fins on the rocket open up to stabilize its flight path for its intended target. Remember the warhead or grenade we talked about earlier? This is how it works. It first hits the piezoelectric trigger, which activates the detonator. The warhead, along with this conical liner, converges to create a jet of steel and heat ready to penetrate a steel armor plate or vehicle. The drone can also be equipped with different types of ammunition. One option is the shotgun effect, where the blast scatters shrapnel over a wide area, increasing the chances of hitting enemy soldiers. This mechanism can be manually triggered by the operator, allowing for greater control and creating a more significant impact on the battlefield. The reason Ukraine took out these strategic nuclear bombers because they have been wreaking havoc. Let's take a look at how they might work. The three planes can work together as nuclear and attack aircraft. In Stage 1, the Tu-22M can sweep in and target enemies using Kh-22 or 32 long-range supersonic anti-shipping cruise missiles, or the Kinzhal, specifically designed to engage U.S. Navy supercarriers. Meanwhile, the Tupolev Tu-95 can be positioned as a command and control center, while also striking less defended infrastructures like the usual communication towers. This slows down the enemy response in the battlefield. Finally, the Tu-160 Blackjack, also known as the White Swan, would launch cruise missiles once in range. These missiles would travel low and slow under enemy radar to reach their targets. This tactic is typical for all bombers in a nuclear war scenario. The Tu-160 can open its weapon bay doors and release nuclear cruise missiles one after another. These cruise missiles deploy their wings when dropped, and it can fly towards their targets, creating a nuclear explosion upon impact. However, the aftermath of such an attack can cause a nuclear fallout. When a nuclear weapon detonates, dust mixed with radioactive fission products are drawn into the detonation's radius, even spreading towards the attacker's own country and people. This nuclear dust can spread all through Europe, Russia, China, and even the rest of Asia if this happens to explode mid-air. This creates a situation where nobody wins, as it affects a lot of people, including those who initiated the attack. Do check out our original animated video on anti-aircraft gun like the M2.